All right, we're live. Thanks everyone for joining us. Community for F# is back online. Well, I guess it hasn't ever left, but it's been a while since we've had one of these videos. We're happy to have Alfonso Garcia-Caro with us today. He is the author and maintainer of Fable, which I'm sure many of you know. Fable has had a really big year last year. And Alfonso was actually one of our 2016 heroes. So we're going to kick this off with the introduction being basically the 2016 Heroes interview. So thank you for joining us today. And let's jump through some of the questions.
Yeah. Hi,
so
everybody.
What was your first computer?
My first computer, I think it was an Amstrad. Do you know that?
I don't know that one.
I think, yeah, at the time when I was when I was a teenager, more or less, it was here in Spain. It was a Spectrum, Commodore.
Oh yeah, okay.
And yeah, I don't know. My mother picked the Amstrad, so I was using it mainly for playing games.
Okay.
But I did learn some programming with BASIC, and I wrote a couple of very short text adventures. That you go there and kill the monster or something like that. Yeah, it was fun.
Very cool. Where do you live, and what do you do for a living?
So I'm living in Madrid, in Spain, and for a living now I'm freelancing, and I'm working on a couple of projects, and I'm lucky enough to be able to use Fable, the F# JavaScript compiler, also professionally nowadays. So quite happy about that.
That's fantastic. How did you get into F#?
So I was actually I studied some computer science at the university, but I got my degree in linguistics, and I was working as a Spanish teacher in Japan, and then I went to Germany. I was working there as a Japanese to Spanish translator, and I was doing several things. But then I discovered that there were many tasks that could be automated in our daily routine, and I started to read about Visual Basic at the beginning to make some macros for Office, for Excel, for example. And then little by little, I started to discover C#, which was possible to do Microsoft Windows application at the time. And then when I decided to go back to Spain, I wanted to keep on my career as a programmer. And I was exploring new things, and I was very comfortable in .NET ecosystem. But I wanted something else, and I found I started also to do some web developing with JavaScript, HTML, and I also discovered F# and functional programming. I thought it was really interesting, so I started to practice more, to read more about that, and also it was really good for me because it was also the time when I started to contribute and be part of the community. So. For me, F# and this open source and the community is very related. So it's that's one of the reasons it's very there for me, the language.
That's really cool. What is your favorite F# open source project and why? And yes, this can be your own project, or it could be others if you like.
It's a Fable. No. It's of course, Fable has to be my favorite because it's the one I'm spending the most hours with. So, I like Fable not because of the project itself, but because of the community that is building around it. So I'm very happy about that. And recently, I'm also I like very much 2 other projects that have appeared in the Fable ecosystem. But I didn't have anything. I wasn't involved at all with this project. So that's also, I think, I'm very proud of that. Fable spawned other projects that I didn't need to do anything. So, for example, Elmish and Fulma, especially in this, that I want to talk a bit later about them as well.
Excellent. Yeah, you've used both of those, and those are both excellent
Cool.
projects on top of Fable. So. Mm-hmm. I can understand why those would be some of your favorites. What other languages do you use and or like? This would be programming languages. You could also mention any spoken languages that you,
okay.
given your linguistics background.
Yeah. No, spoken languages. I'm only using mostly English professionally because I work with clients abroad, and Spanish and Japanese in my daily life. unfortunately, Japanese not professionally very much. I would like to do something related to Japanese, but yeah, programming language is I think for almost 2 years I've been using mostly F#. It was before that it was C# mainly, and I still do a little C# sometimes. It's a language I like. It's not like that I don't want to do C# anymore, but I'm also very comfortable also with F#. So if there is any project with that I can use F#, usually I try to take that one. And of course, because of web development, I'm using JavaScript, and I was using TypeScript before, and I also like it. I think it's a bit of SQL sometimes to deal with databases, but I don't know so many languages. If you take me out of there and you put me some I don't know, Haskell or C++, something like that, I get lost very quickly. So I'm not such a polyglot with programming languages.
Okay. Cool. And then last question, who in the F# community should more people know about?
I think, of course, I'll try to promote some people from the who are helping a lot and contributing a lot to the community in the Fable ecosystem. So I think Maxime Angel, he's making a lot of. He's the author of Fulma. He's been also contributing to Almis and Almis templates, for example, and he's doing a lot of things. And I think people should know more about him. And also in Cave. But this very mysterious contributor, because nobody knows who he or she is. So, but it's doing a great work, especially he has helped put the whole F# compiler. We'll see it a bit later, to put into Fable and compile it to JavaScript. And that's how we are using the Fable repo at the moment, that you can do everything in the browser without any server. And yeah, it's pretty cool.
That is really cool.
Mm-hmm.
Awesome. Well, that's all for the questions. Thank you again for all that you've been doing. Obviously, you've been recognized as one of the community heroes, so thank you for that. And again, as I mentioned earlier, Fable had a huge year last year. You had your first conference.
Yes.
The whole safe template thing came out. So there's been a lot going on, and I'm sure a lot of people are very interested, or if they haven't already used Fable, probably should. So, Alfonso, thank you for joining us today, and we look forward to what you have to share with us.
Mm-hmm. Thanks, you. So, okay, let's go. I think I have a few slides. As you said, we had a great year last year. It was the first year also when we did I'm going to share my screen. When we did FableConf. So it's already outdated, but we had a really great time. And maybe if you go to Twitter and you search for FableConf, you see some of the things that happened there, and it was really nice, and gathering the community there, and it was a great location, and meeting some of the people like Francois that we met before only through the internet, but was the time to see us face to face. So it was really great. We are trying to organize it for this year as well. So I hope to see everybody there. And
do you have any updated information about this year's conference?
Not yet. We are trying to decide the location and things like this, but we don't have the information and nor the date. So I just want to try to decide everything quickly, because I know that when it's a bit later in the year, I'll have many other things to do, and I'll regret making that decision. So I think I should do it when I'm still a bit available. But let's see. Okay, so I think I have to. Let's see some slides. These are very simple. Sorry, I just created them a couple of hours ago. So this, of course, is Fable, what we'll be talking about today. This is the web page, Fable, very simple, fable.io. But thanks to Thomas Petrusheger, we could get the domain, so I'm very happy about that. And first thing we are going to talk is what's Fable. So probably everybody know that it's an F# to JavaScript compiler. This is something I want to stress, and it's important because it's just an F# to JavaScript compiler. This means that there is nothing. It's not opinionated in the sense that it doesn't come with a framework or any idea of how you should be doing web development. Actually, because JavaScript now you can use in many platforms like mobile, for example, or even the server with Node.js. You can use Fable also for that. I'm going to talk later about a couple of projects that like Elmis and Fulma, but these are independent of the compiler. So this is not tied with the compiler in any ways. And another important feature of Fable is that it comes with a battery chart because it's compatible with most of F# core and some of the base class library. Just a little bit because the base class library is really big, and some things like a file system, for example, you cannot do it with in the browser. But you can go to Fable, you can go to the docs. The docs are really they are really small, so they are just actually 3 pages. So if you're interested in Fable, I recommend reading them because you can read them very quickly, and most of the questions that people ask sometimes they are replied here. So it's good if you can have a look. So if we go to the language and library compatibility, you can see here some of the things that are supported. So in the .NET base class library, we have the numeric types, even big int, for example. We can use the big integers with Fable. We have arrays, events, the typical primitive types. And also gits, for example, we can generate unique identifiers easily with Fable. We have time span, the datetime, also with formatting capabilities, datetime with offset as well. Timer, we have the usual mutable collections like list, hash set, or dictionary. We have regular expressions. These compile to regular expression in JavaScript, but we can use the API from .NET. For example, this was one of the reasons for me when I started trying FunScript before, that I never managed to learn the API for regular expressions in JavaScript. So it was important for me to be able to just translate whatever I was using in .NET. We also have lazy types and random and some of the functions from the math module. And we can also print to the console. We can also do debug statements for printing. These are very helpful because it means that when you are compiling for production, this won't appear in your code. And in JavaScript, it's very important to take all the code that you are not going to use in production because it's very important to have small bundles sizes. So we have here some of the caveats, that some of the things that you need to be aware of when writing a Fable application. So, for example, all the numeric types will be compiled to JavaScript number. Even decimal, I like to have a specific type for decimal in the future because so to get more precision. But we can use long, and with this we'll get the full range of in the 64. And we can also use big integers, which is very interesting. And numeric arrays will be compiled to type arrays. If you go to the link, you'll see that type arrays is a way in JavaScript to create arrays that are actually typed, so they are much more performant, especially when dealing, for example, with Canvas or doing things like this pixel manipulation. And they are a bit cumbersome to use from directly from F# because, as you can see, it's a bit more verbose than a simple JavaScript array. But with Fable, you get them for free. So this is also one of the performance tricks that you can get using Fable. And from the F# core, we are also supporting many types like tuples, option, result, choice, all the functions in a string module, in sec, in the collections, list, map, and set, for example. We can use also async on the computation expressions as well. We can do our own computation expressions. We can do use observable. We can use the events, and even mailbox processor, even if it has some limited support, that you can see that it's just a single thread, because JavaScript is single thread unless you use a web worker. We have also some of the semantics of F#, like using a structural equality and comparison for records and unions. We can use comprehension, again, computation expression. Pattern matching is very, very important, and active patterns, and also object expression and units of measure. You can use them in your Fable apps as well. Again, a couple of caveats, especially one thing that it was a design decision. At the beginning, there was the options will be erased. So, for example, if you write some 5, it will become just 5. But this is still working, because we have we introduced some checks at runtime when needed, and this was we did it like this because we wanted to represent TypeScript optional properties, because we were thinking to use TypeScript declaration files to make bindings for JavaScript libraries. So in TypeScript, you can say that a property can be there or not, and we didn't know how to implement that in F#, and so that's the reason that we made it with option type, but it means that the options will be erased in runtime. Again, you can do also object-oriented programming, like classes, inheritance. You can use interfaces as well. You can use generics. So generics, we have a trade-off here, because one of the guidelines in Fable is that we want to add as less overhead as possible when outputting JavaScript. And so this means that the generic information is erased in runtime. But in some cases, when you do need to read generic information, like, for example, if you are doing type of or things like this, you can use the pass generic attribute. So this will tell Fable that it should pass generic information to the calling function. And we can even use some reflection. So this is useful for some use cases. So, for example, you can here you can take the fields of a record. You can take here you can take the cases of a union. So everything that you see here in Fable test, these tests are run both in .NET and Fable. So this means things like that you can see here. It means that it is supported by Fable. And if you see something that is not, it's failing or is not supported, if you send an issue with a failing test, it's really, really helpful. So we can add it to the test suite. We have around 1,400 tests at the moment. So this makes the application very robust. And okay, so let's go back to the slides here. And also, one of the goals of Fable is to serve as a bridge between the .NET and the JavaScript ecosystems. This is, I think, this is unlike other compilers to JavaScript that they try to hide everything JavaScript related to the developers. Because, for example, there are some compilers for .NET developers that they mean that they want developers that they don't need to know anything, or they don't need to know much about the JavaScript or HTML. But in Fable, it's not like this, because as we said, it's not opinionated. So it means that you need to know a bit about the JavaScript. This can be an advantage or a drawback for some people, because you need this knowledge. But it's also a standard knowledge. So it's knowledge that you can read in Mozilla Developer Network, or you don't need any special knowledge just to use Fable. And it's also knowledge that will be useful for you in the future. So we're trying to replace the what. Let's try to replace the why. So why should you be using Fable? So one of the reasons is that you can use the power of F# in your web application, as we just saw. F# is a functional first statically typed language. It's a safe language with powerful features. And if you want to use it instead of JavaScript, or side by side with JavaScript, because the JavaScript interaction is also very good. You just need to go again to the documentations, and you can check the interacting with JavaScript. So you'll see that it's really, really easy. You can also check this guy by Zaid Ayad. It's also, he has also great examples about how to interact between F# and JavaScript using Fable. So sorry again here. This it's also, I think it's also an advantage to use the same language on the back and front ends of your application, especially because you can reuse your knowledge if you are proficient in F#. You can use this knowledge of the APIs and the knowledge, the F# semantics. You can use them when designing the front end. And also, I think it's important because you can share the domain, you can share the types, and you can share some code, especially the validation code. So if you have some types and your user is typing a form, and then you convert it to a data, to a type, and you validate it, you send it to a server, but for security, you need to validate it again on the server side. So you can just use the same code. And it's this is useful. And another reason is will be to use will be for performance, because thanks to the static types, we can make some tricks to optimize the code that is being generated. I must say that it's this hasn't been a priority so far for Fable. So far, we try to output readable JavaScript. So not so much as performance JavaScript, but we are now working the next major version, so in Fable 2.0. And for this, we are taking good care of performance. And I think, yeah, it will be very good. We have, for example, this very simple example here in this tweet that we have performance, just the map function from Fable. The array map function is it can be 5 times faster than the JavaScript array map. I think this is just because we know that the final length of the resultant array, and we can make some assessment that for JavaScript is more difficult because it's highly dynamic. So you never know what's going to happen. But in our case, in F#, we know that if we have an int, by checking the types of the function, we know exactly what kind of array we are going to get. So we can allocate some things in advance. So I want to show you one of the examples of the things that you can do with Fable. If you go to the homepage, you can see here on the bottom of the page some of the companies and the projects that are using Fable. So, for example, Ionide, if you're using F# with Visual Studio Code, probably you know that there is a great extension to use F#, which is called Ionide. And this one is made with Fable. So it's not only to make web applications, because you can do anything that you can use JavaScript for. So in this case, Visual Studio Applications. So you have here several companies that are using also this great project by Thomas Petschek, the Gamma.net. Probably you have seen it. So this is also using Fable in the background. And one of the most impressive things, I was talking about that when I mentioned about Encave, and also Maxime has been helping a lot to create a new version of the REPL. We have a REPL here that is maybe I have to say that when I'm streaming video, my computer may seem slower. Well, it's actually slower because I'm streaming the video. So if you see that things are running slowly, don't take it for granted that Fable is slow, because the compiler is usually fast enough for a great development experience. But you have to try it in your computer. So in this case here, we have, this is we can compile here. So you can see the generated code. As I told you, it's really, really simple, very readable JavaScript. You can see here some reflection information that we have available. And we can have some fun here. Oops. Yeah. Okay. Here we have the canvas. We can see the example, and we can make some changes. Press Alt, press Enter, and you see that it's happening live. Okay. It's also changing here and of course, you cannot see it, but I'm using exactly the same shortcuts I'm using with Visual Studio Code, because this is Monaco, which is Visual Studio Code on the web. And so you have not totally, but you have a very close experience to what you can have in with F# and Fable using Ionite directly on the web. We don't have. I want to show you here the network. I can check here. So you see here that I'm getting some type auto completion. I get some results, some errors. So it's telling me. In this case, not very helpful. But if I do something like this, it will tell me the error message. And all of this, as you can see, this is not communicating with the server in any way. So this means that it's happening everything just in the browser. This is the full, almost full F# compiler compiled to JavaScript using Fable and Fable itself, because Fable is compiling to JavaScript here. So this means this is you can see here also the tooltips we have. So this is an example of what you can do with Fable. So if you can compile the full F# compiler, it means that most of the applications will be fine just running Fable. Again here. Oops. Oh, sorry. That's okay. And we can even play this. We have here the Mandelbrot sample, original from Thomas Pejcek. And it's been improved recently, so you can even zoom. And I cannot play much with it because I don't know how this code is working. But you can make some changes. For example, here let's put a 5 just for fun. I'm using Control-Safe all the time. Sorry, this is Alt press Enter. So you see, depending on the number I put here, the colors are going to be a bit different. Again, sorry, a bit. And we can even use the games from Field Truffle. We have Mario here. Okay, this is Mario. I need some more space. Okay, Mario doesn't want to jump today. I don't know why. Sorry. But we have also here this really funny game. It's very simple, but it's very addictive. Also by Philip Truffle. You can you need to get here, and you can just edit it on the fly. So, for example, if you want the atmosphere to be smaller, you can touch with this. So this is this everything happening in the browser, and thanks to the F# compiler and Fable, and to NK, who was who did all the work to compile the F# compiler to JavaScript using Fable. So let's go. If we go again to the, if we go again to the home page, you can see we have the REPL, the docs we have seen. You have some of the API in Fable core. We have a blog. We don't post that often, but we do have a blog if you want to read. We have some samples here. These are some of the samples that you saw there. We also have samples with React, with T3, for example. And for this, you can go to the GitHub repository, and you can check them. You can check the samples, for example, for Fan Snake. Everything's here. And we have a sample with Pixie, which is a library, a JavaScript library to render things using Canvas and WebGL. And it's very good for games, for example. And Francois, who was who made who was one of the organizers of FableConf, he made this site as well with samples with Pixie, which are really fun and very nice. And there is even a small game. So we can start and can put. I'm really bad at it. Okay, good. So you see, just have to drag cogs to the proper place. And let's yeah, you have many samples, and like how you can click on a sprite. You can render some texture. You can drag some of the sprites, so it's very useful for games. And yeah, particles here around the awesome Fable logo, which was made by the Sergey Tion. Everybody in the F# communities knows him, thanks to F# Weekly. So he also designed our logo. So and we are very grateful for that. And I think that should be okay. And the same, you can go to the GitHub. Oh, this is pointing to the repository, Fable repository, but you can go to, oops, sorry. You can go to samples Pixie, and you can also see the source code of all the samples here.
If I may say, I think the documentation and especially the samples that are on the website are actually quite fantastic. It's a great resource for people who are trying to understand what you can do and where to go.
Yeah, the community has been helping a lot, and I think that I totally agree that the documentation and the samples are really important. It's because I was, of course, FunScript, if you know it, that it was the previous F# to JavaScript compiler. It was a big inspiration for me, and it also had very nice samples, and that's what actually some of these samples like Fable Mario and Pac-Man, for example, they come from FunScript, so, and FunSnake as well. That's what it's called, FunScript, or even this one with 3GS, for example. This was also done with FunScript. And we ported to Fable. So yeah, it's obviously it's really important for the people who are new to get a quick grasp of what a tool is capable of. So absolutely, it's really important. And I also think that the REPL is very good. We still have to improve things, and it needs a bit more work. But I also think it's a very good way, without installing anything in your computer. You can quickly try out things, have a look at how the code is being generated. So you can have you can try it out. You have the HTML here. You can try the the code here in JavaScript. So yeah, this has been thanks to the community, but we tried a lot to make a great experience for developers. So. You were talking before about our last year. That was a good year. Actually, we are starting the third year for Fable. So it was released at the beginning of 2016. So I like to say that the first year was the year of prototyping. We have very brave developers that were trying Fable in the early stages, and were giving very good feedback. And we were improving the developer experience, and there were many changes very quickly. Last year, I like to say that this was the year of integration, and also quick expansion as well. And we tried to integrate with the new .NET SDK and NetCore, thanks to the work by Enrico Sada. And we also, as we said before about the bridge between the ecosystem, we were also integrating with Packet and NetCore on the .NET side, but also with Webpack, for example, on the JavaScript side. And this has opened opportunity to get many improvements from the JavaScript community, with especially about the hot model replacement, and having a very quick response from the when you are just designing something. So basically, what we have here, that you can get a response very quickly. So you just make a quick change. Using the wrong shortcut, and you can see the change immediately. So you can have the same experience on the when you are working with the proper IDE. So let's check that.
Is the REPL using the hot reloading in addition to using the full compiler in the browser?
It's not using hot reloading per se, because if you see here, for example, in the game, we are actually, oops, come on. No, it's because it takes it has to download some libraries, and at the beginning it takes a few seconds to load. So if we compile, so if we make a change here, sorry for that. You see that the stage is being renewed, so it means that this iframe, and it's been reloaded. But on using Webpack and Fable CLI, I like to call it, you can reload the new code without restarting the app, and this is really useful for development, especially for static web apps, single-page web apps. Sorry. Let's see how is that. Here in the documentation, we have this page about getting started. So you can see here the requirements. This is usually very common for developers, web developers nowadays, about having the .NET SDK, having Node.js. We are using on the net side, we are using Packet, but this usually comes embedded in the template, so you don't have to worry about installing it. But for JavaScript, we use npm or Yarn, which is also very favored by the community. You need an editor, and I use personally Ionite because it's fantastic. But you can also use Visual Studio and even Emacs with F# mode, or Rider, which is the new IDE by JetBrains. So this is I'm not going to read it, because we are just going to do this, just installing the template. But here you also have a bit longer explanation about how Fable works. It's not actually very long, so if you are interested, I recommend you to read it. And it explains a bit about the two hearts of Fable, which is the .NET side, which is translating the F# code, and the JavaScript side, which is taking the AST produced by Fable and turning it to actual JavaScript code using Babel, which is where the Fable names come from, because we are using this tool, which is amazing, and as well as Webpack, the people around it, and they are amazing as well, the maintainers and the contributors. And I'm really happy to be also part of the JavaScript community, and they are really welcoming, and they are not. I think this is mainly because they have so many developers that they don't care about a new player coming into town. But yeah, they are very welcoming to to any language, anybody that wants to target JavaScript and its ecosystem. So I'm also very happy about that. So let's try to do this the steps you can see here to install the template. So let's open a terminal. Let's open a new one. So here, first we have to new. It's a way to install. It's readable, Ryan, the code here in the screen, more or less. Hello.
Yeah. Yes, it's good. Sorry, I was on mute.
I thought I was talking alone for all this time. No, don't worry. Okay, so if you type .NET New, this the templates installed with .NET, so we can just install the Fable template like this. I already have it in my system, so hopefully this will be fast. Now we can just say .NET Fable. We can give a name to my app, and it's been reported that this should be enough, but it's been reported that with the latest .NET SDK there is a bug, so you need to specify the language. So do this for now. I think they will fix in a next upcoming version, but for now you have to specify that you are using the F# language. So it is there. We already have it here. So let's open with Visual Studio Code and Ionide. So the first thing you need to check is the README, which is going to explain you about again about the requirements, the editor. This is going to explain you a bit about the project structure and the tools used. And we are going to focus on this part. Okay, so here, running the app. Okay, so first we need to install the JavaScript and .NET dependencies. So we are going to do this using Yarn and .NET Restore, which is if you know a bit about Yarn, is using package.json, but it also has here a log file. So to be sure that all the machines are using the same dependencies, not only direct dependencies, but also transitive dependencies. And thanks to Packet, we also have this on .NET side. We have a very simple dependencies here, but now in the .NET standard world, this hides many other dependencies. So it's good that we have a tool here, Packet Log, which is automatically generated. It's taking care that we have the same thing in all the machines. So this already finished. Can you see? Oh, no. So the README says that no, we have to move to the src directory and type .NET Fable yarn star. So this is basically starting, it's explaining the documentation, this is starting the Fable daemon, which is going to get a request from Webpack to compile the files. And Webpack is a tool that is going to bundle all the generated JavaScript files and with our dependencies. And in this case also, it has a development server with hot reloading to make development much easier. And the thing with Webpack is that sometimes you need a big configuration file. It's not very big here, but for some people, yeah, it can be a bit confusing sometimes because they need to understand what is everything doing. So we are also trying to work in the to hide this more or less to developers and be able to start faster. But for now, you can just grab the template and usually just by changing here the project name and maybe the output, this is usually enough. So you don't have to worry too much. And now this has finished compilation. So we are going to check. And so this is exactly the same sample as we saw before in the REPL. It's very simple. This is the simple template. We have other templates for creating a full SPA, for example. In this case, it's just to show the very basics of Fable. So again, and now this time I can press Command plus S to save automatically. And if you see in the integrated terminal, this is Webpack is detecting the change automatically. It's recompiling and it's refreshing the web for me. I can hide one of the squares. I can make one square really tall, for example. So, this is also important in Fable because we have this. We want it to be very close to the JavaScript development experience, where your changes are automatically appearing in your application, so you don't have to wait for a very lengthy compilation until you can see the changes. So this is very good to try out things, and it makes this one of the things I like very much from F#, and that's why I think it's a very good language to target JavaScript, because F# also has this nature of a scripting language, so it invites you to try things very quickly. You don't have to, even if it's a functional first programming language, you don't have to think things a lot before trying things. So you can just put some code there and see the results, and then you can later clean it if needed. So let's go back to the presentation. So I want to, we said we reply the what, the why, and I want to reply the what else, George Clooney style now. So these are not the only alternatives, but I wanted to use 3 points for each slide. So we have here 3 points, 3 alternative languages that you can use when instead of Fable, if you want, because we want to be fair. And we want to show our competitors, and we want to show also why you shouldn't be using them. No, just kidding. Each of them has a bit different philosophy, so please check them out and choose whatever fits you best. So first, you can use TypeScript. TypeScript, probably everybody knows about it. It's also a language sponsored by Microsoft, and it can be said that it's JavaScript with types. So it's very close to JavaScript, so it's mainly a superset of JavaScript, just adding types, and it has a very good tooling. You can go to TypeScript. Also has a playground where you can check things. But it's if you're looking for something else, it may be not enough, because it's just compiling to JavaScript, so you cannot do this. For example, these performance tricks we were talking about with Fable, because it's just basically what it's the same as writing TypeScript with a type checker or something like that. We have also Elm. You can check Elm lang. Yeah, let me check this. Okay, now. Lang, Elm, it's been a huge source of inspiration for Fable, especially for Elmish, and this is this language is very interesting because I haven't used it much, so I cannot talk too much about it. But it enforces purity. It's inspired by Haskell, but it's simpler than Haskell, and it also has the architecture we are going to talk about later. So it's an ad hoc language, which can be an advantage, because they don't have to cover other purposes other than creating web pages. So this is a good thing, because if you want to be very focused and you want to have a language that's focused on this task, Elm can be a good opportunity. It enforces purity, which sometimes it makes interactivity with JavaScript harder. But on the other hand, it makes the application is safer because you won't get undefined values from JavaScript, for example. And finally, one of the latest guests to the party is Reason, which is, if you know, probably most of you know about OCaml, which is the language that is where F# also comes from. So this backend script, which is a compiler from OCaml to JavaScript, but now Facebook released a Reason, which is like a dialect from OCaml, and this is especially targeted to JavaScript developers. So you can see things like here, like semicolons or brackets, for example. So, but it can be, I don't know, you can like it or not, but it's also baked by Facebook, which is important for some people to know that it's something is baked by a very powerful company. We're just a small community, but it's also the good thing about the open source that just single developers and community and the big companies can play together on the same level. But yeah, these are the other alternatives that you can have a look at if you want. So I want to talk. Yes,
there's a question from Woodworking Fangirl. Mm-hmm. She asks, how good is the tooling in Visual Studio 2017 compared to Visual Studio Code for Fable?
This is interesting because until recently, when we moved to .NET SDK, this means that for a time, Fable wasn't compatible with Visual Studio for Windows, Visual Studio 2017, because Visual Studio took a while to support the new F# project system, project format, sorry. So I think they added this recently, but now I'm mostly working with Visual Studio Code, so I cannot tell. I think it should work because now the only showstopper was the lack of support for the new F# project format. But now it's there, so it should work. Fable is just a CLI application, so you just need to run something on the command line, and you don't need to worry about anything. So the Fable and Webpack will watch the files. So every time that you make a change, it will reload everything automatically. So it's not related to any IDE. It has something with the Visual Studio Code if you want to show some errors, but you can use it with any IDE, even Emacs or Rider. So it should work. I haven't talked to anybody yet using Visual Studio 2017, but I guess it should work now. Maybe he can try and tell us. So should I keep on?
Yeah, please do. Thank you for answering.
No problem. Anytime if you see any question or do you have any question yourself, just interrupt me, because I'm Spanish. I talk too much and I forget about the other people. So it's good that you interrupt me. So please do it. So to end the slides, I'm going to talk about UI architectures. This is not going to be very academic, so I'm going to mix some concepts, but just to have a very rough idea, I want to tell you a bit about my way until I came to Elmish with Fable. So we are going to talk about three types of UI architectures, which is one is the imperative. I associate with Windows Forms and jQuery, for example, on the web. We also have the model view model that was popularized by WCF. This WPF. Sorry, I think this is wrong. The Windows Presentation Foundation. This different acronym. But yeah, SAML and such. And I think I may be wrong, but I think the web now Vue.js is very close to this model, and a model that is what I'm going to talk about more. Is about the Elmish model or model view update, which is used For example, it's been popularized by Elm. Sometimes we talk about Elm architecture, and also Redux, for example, for React applications. So let's talk about the imperative. This is if any of you have done any Windows Form or jQuery applications, so you'll know that you have to manipulate the UI directly, the components. So you take something out, you put something in. And in most of the cases, especially with Windows Form, for example, in Java, you have something similar. You have already a component library that you can use, and sometimes, most often, you have a designer, which is very useful. So this is one of the pros that with Windows Form, for example, it was very good for rapid prototyping. But on the con side, is the UIs weren't very dynamic because manipulating the UI was difficult, and it was difficult to create custom components and also to manage the state, because you had to be sure that you were making the same, you were making the changes in the UI that the changes to correspond to the changes in your state data. So this was difficult. So then the model view model architecture came, and this came with a bidirectional binding. So you just created view as the UI, the model is your data, and you had something in between. It was still in C#, for example, it was just a C# class that was between the two, and there were some bindings, usually sometimes automatically generated between the view and the view model. And with that, you could have the view model automatically updated, and this could communicate with the model. And these bindings were bidirectional, so it means that when you made a change to the model, it will reflect the view. And when you made a change in the view, or there was an event, for example, or a switch, it will be reflecting in the view model. So it sometimes it's also related to reactive programming, because it means that the other side has to react to the changes from the other side. So and also in many cases, I've seen that there is they use a declarative language for the UI. So for example, they with WPF they had SAML to what's an XML language, a bit resembling to HTML, that you could use to express your UI declaratively without a designer, although there was also a designer. And the pros, it was easy to create components, and there was automatic wiring between the data and the UI. And the cons were that there was some magic involved, especially the magic strings that you had to type the strings in the declarative language, and if you make any spelling mistake, this will mean that the binding would break. And also, it's especially if you are coming from a functional background, there were control mutations. So it means that there's something happening in the UI. It will change your view model, and this could be sometimes difficult to control. But then we come. It's not exactly an evolution, but you could see it as an evolution. The model view update model, which is very simple. It's just it's involving just this. So it involves a model, a view function, and a update function. And the changes are happening unidirectional. So it means that the model is going to you are going to send the model to the view function. The view function is going to generate the UI, and the UI is not going to send changes directly to the model. It's going to send messages, and the update function is going to check these messages and update the model. So this was happening only, it's not like the unidirectional bindings. You can, if you want to know more about the architecture, you can go to the Elm page. You can see the Elm architecture too. And there is also right. Also, the Fable Elmis website here as well, and you can read. There are also some samples, yeah, that you can use. It's a game calculator. And it also has a very nice documentation for the architecture here. It's explaining a few more concepts. And it's showing you how the loop is working. So you have the program is going to render the view. The view is going to trigger messages, and the program is going to call the update function to create the new model. And when there is a new model, the view function will be called again to generate the view. One very big difference is that the view is being generated in full all the time. So it's not like with the imperative architecture that you had to modify only the parts that were being modified. In this case, the view every time is getting a new instance, a new copy of the model, and it's going to generate the full view with that. Let's close.
I'm not sure if this is a good time for another question.
Yeah, Tony, of course.
It's not directly related to the architecture, but it does involve features that are supported by Fable. Dimitri asked if type providers were supported. I assume he means the types generated by type providers.
Yeah. This is complicated because when there were some problems at the beginning, but then they fixed that in the F# compiler services. And we did have some type providers, so there were some type providers working. Most of the time, the tricky part with the type providers is that they were erasing the code using some APIs from the BSCL that wasn't compatible with Fable. For example, we were using we wanted to port the Swagger provider, but this was using system.web or the HTTP client from .NET, which wasn't compatible with Fable. So you could use the type provider, but then Fable didn't know what to do with the code. So that was the difficult part to port some type providers to Fable. But then we moved to NetCore, and because type providers had some problems with NetCore, we kind of forgot about the type providers. So I don't know. At the moment, it's been a while since I haven't used a type provider. So I think that they are working now with NetCore, but they still have some issues. So I don't know. Probably we can visit them again at one point. But right now, I cannot tell for sure if they are working or not. I think there are no type providers available for Fable. So you can say that there is no history at the moment for type providers on Fable. But hopefully in the future, when we work better with NetCore and we support more APIs, it will be easier to have more type providers with Fable.
Cool. So it sounds like if you do use type providers on your server-side application, you'd want to create your own types and map into those types to use with Fable.
For the you're talking about the generative provider here, right?
No, I'm just saying if you are using, like if you're using one of the SQL providers or F# data on your server side and it's generating types that you're using, and you want to create something you would want to use on the Fable side on the front end, you would need to create your own types and then map the data into those types in order for Fable to translate it properly.
Yeah, I think so. Probably, yeah. If you use SQL or something like that, you probably need to type something by hand if you want to share with Fable side. I think probably, yeah.
Awesome, thank you.
So we are okay. Let's go back to the architecture. So we were saying that it was unidirectional, and we say that the UI communicates with just by dispatching messages. So the UI doesn't modify the model directly, and there is only a single source of truth, because there is always a single copy of the model at any point of time, and this model is immutable. So the update function is going to always output a new instance of the model. So what this brings to us, so it brings immutability, because the model doesn't mutate, it's just a new model every time. And also, it's very interesting because with Elm, with Redux on React, for example, and also with Fable, we use the same language for logic and UI. So this means that especially when you are generating a provider, you don't need to learn about a template, for example, because you can already use the full power of your logic language, F# or JavaScript, to just generate the UI in real time. And because we have these immutable models, and we have like a snapshot of each change of the model, we can do type travel debugging. So this is also very convenient. We'll see some example later. And on the con side, so we have to. Some people don't like that we have to wire everything explicitly. So sometimes this can be a bit more code, because it's not like the view model that the bindings in some cases were automatically generated. But on the other hand, some people like it because it's more, you can control more, and especially because we use in language like Elm or F#, we can use unions, discriminated unions, and pattern matching, and the compiler will tell us if we forget to, when we make a change, the compiler will tell us if we are forgetting to handle this new case somewhere else. So this is also good. And I've seen mainly there are some attempts to port this to WPF, for example. I haven't looked very much at those in depth, but on the web, for example, they need like a virtual DOM for the performance, because we say that this is going to generate the view every time, the full view. So there is a virtual DOM that is going to check the view you generated and the actual DOM, and it's going to just take the differences, and this is going to only this is what is going to be changed, because if you change you render everything at every frame at every time, it's going to be I don't know, it's not going to work well. So you need this virtual DOM. In this case, Elm has one, and for Fable we use React, which is very popular. Probably everybody knows about them. But yeah, it's a very popular JavaScript library for rendering with this style, also by Facebook, which is releasing a lot of the popular JavaScript tools nowadays. So let's have a look at an application. I'm going to show you check. We are going to check the Fulma demo. So we talked briefly about Fulma before. Let's take because it has a very wonderful type. Here, Fulma, it's also on GitHub, project by Maxim. So it has a very wonderful documentation. So basically, this is just taking a Bulma. Oops. Bulma, which is a CX framework. Think of something similar to Bootstrap. And I like it very much because it's Flexbox base, which is the new way to expand the layout in HTML now, much easier than before. And it's also, it hasn't any JavaScript, which is very useful because you can combine it with anything. And it's really nice. You can have a look here of the layout, the forms. Yeah, for example, it's very easy to use. But it means if you want to use this with React, for example, you need to learn about you need to remember about all these classes and put them correctly, and you have to check the documentation all the time. So then is where Fulma helps us, because this is giving us a lot of helpers. So mostly, almost everything that we can do with Bulma, it's possible to do it with Fulma in a type-safe way. So you can do something like this, for example, for columns, for containers. You want to create a footer, or you want to create a box, for example, here. Notification. You can check the code here. You can put it in your application. You have some components here, like a card or a model. So you can show a model here. It's very useful. You can also have some extensions, like the calendar. Yeah. Or we have the page loader. You can show, well, you are loading a page. So I recommend everybody who is interested in creating web applications using F# and Fable to have a look at this project, because as I said, it's independent of the compiler, so it's possible not to use it. But I recommend to use it because it's really, it really helps you your developer experience. So let's have a look at the project here. We have these are our files. Again, we have packet, we have a yarn log, the package.json. We are going to check the project directly. And as you can see, one very common structure of emits application is that you have these 3 files, which are types, the state, and the app also is called the view. So here you have types, state, view. Sometimes you also have REST here, which is this is where they go to communicate with the server, or in this case, actually, because it's just a client application, this is communicating with a local storage. But you see that the structure is repeated every time for each component. So you have the types, REST, if sometimes it's this option. You have the state, which is basically here you have two functions. One option is to initialize the state, and the other option is to update the state. So as we said, the update function receives a message and the previous model, and it's going to output a new model, and we are going to talk about commands later. And the view function here, may call the root or view, it's going to call to receive a model, and it's going to receive a dispatch function. The dispatch function is what is being called to dispatch a message. So one of the good things about using a language like F# is that it's very easy to compose things. So as you can say, we can compose. We have to make a difference between when we are building an application like this and we are generating a view using composing functions. We have to tell the difference between just composing functions and using actual components. I'm not going to explain about the components here, but you can go to React and read about the components. So you can read about the components here, and also some in emits, because you have a single source of truth. Usually you have all your states in a single place, but the components can also have their own state, and they also have a life cycle. So sometimes it's useful to know about this, but you can take the documentation. But what I want you to know now is that one thing is just composing functions, which is it works the same as a function composition. So there is nothing special about that. And the other thing is using components that they'll have their own life cycle, and probably also they may have their own state. So as you can see here, this is we have the same as we saw in the web. So if we have the level, we can check the Bullman documentation. The level is a very easy way to keep things vertically centered in the same level. So if we want to do this with F#, we have here an example. You can just copy it and paste it into your application and adapt it as needed. So here, and the good thing about Fulma is that everything's statically typed. So if you make any mistake, the compiler is going to tell you immediately. And also, you have auto completion. So every time that you write something, you can see what do you have available there. Let's say that Maxime is working right now in an update of the API. So this may change a bit in the next few days, but yeah, it will remain more or less similar, and you'll be able to use your applications. And it's actually going to improve a lot. So this is good news as well. So let me show you an example. So for example, we have here, this is the view for the replies. And when we click the button, we have a button, and when we click the button, we're going to send a message. That's the message submit. So here in the type section, you have all the types. You have usually in the types you have two main types, which is the model that the component is going to use, and the message that the component is going to accept. So as you can see, it's really simple. It's just you have a view function. Let's start for the app. Let's say first you have the types, which is the model and the messages. Then you have two functions to manage the state, which is one for initialization and the other one for updating the model, which will receive a message, and the previous model. And in this case, now I'm not going because yeah, I'm already talking a lot. I'm not going to talk about that, but you can also handle navigation. And again, you can go to the wonderful documentation. And here, I think in a browser, yeah, in browser, you have the navigation. So you can also here check how to parse routes. Yeah, we are talking here about navigation with a single page app. So the navigation is happening in the, it's just using the hash. So it's everything happening on the client side. But you get browser histories and all the benefits of, for example, you can also copy links and send to another person. Actually, I'm talking a lot, but I guess everybody wants to see this in action. So let's run Fable with a Webpack dev server. So again, first time takes a few seconds to compile the whole project, but then after that, Fable and DevShop compiler are going to compile only the file that had the change and the dependent files. So this makes the changes very, very quick. Okay. This is a bigger process, so it takes a bit longer, but we already have it here. So it's a simple app, but it has stylings, and it has the nav bar that you can see. You can open it, and you can see the options here to reset the demo. So it's an option where you can like something, you can dislike it, and you can reply. You can use Markdown. And submit it here. But one of the interesting things that we talked that we have talked about the integration with Fable of Fable with the JavaScript ecosystem, and also about the emits architecture that you can have a snapshot of every state update. So we can use tools that originally they were thought for JavaScript. In this case, called the Redux Dev Tools. You can find it. So you can find it here. I don't know if this one. This one. So you can see that I already have installed. Have it here. So you see, it's already this because I'm developing the debug mode. So this already it has recorded several messages, and I wrote here. And because every time you see the message, we have a new message. Every time that I type something, we have the state, the full state of our application. It's related to JavaScript, to like JavaScript if you want to, send it by JSON, for example. We have the divs. It will tell us what is exactly changing in our model. And most importantly, we can travel in time. So as you can see here, I'm just moving. I'm just going through all my update history. Even, you see the likes here. Even navigation, or even opening the menu, because everything is in the model. So if you go to the model here, you saw here in the model that we have the is burger open. So we have this message, toggle burger, that is being dispatched by the navigation bar. So every time that I click here, it's going to dispatch the open burger model, and it's going to update my model. So as I said, one of the things with this architecture is that you have to wire up all the events manually, but in a sense, this makes everything more predictable. So it's easier to reason about, and you have more control over the application. Some people, for some people, it's a bit too much. So it you can also use some abstractions, some components, which is, for example, what Fulma does. That it's helping you with CSS, for example. So here we have hey everybody. I can select reset demo, so it will clear the local storage. Then my answer is gone. So this is, of course, I'm going very quickly because I'm already using a lot of time. But you can go to the source here, Fulma demo, and you can play with it. And when you need actual communication with the server, because this is only client side, a very good example is the Safe book store project, because here you have right now this using Giraffe, and it has Fable on the client side, but you can see how F# is working on the client and the server side by side, sharing types and some code. And here, for example, you have some code for for communicating with the server. We use fetch, which is also a new API for the browser. So you can check the documentation here. You can see how it's been used, and it's using promises. So you can also see here that we have a promise computation expression. The fetch bindings and the promise computation expression, they are coming from Fable Power Pack, which is a library to have some common tools for Fable. This is mainly used for fetch and promise at the moment. It has a few other things as well. But you can check. You don't need to check the code directly. You can check some of the tests, for example. You can see some of the tests. How are you using fetch and using promise to make some change of the asynchronous responses. And we have some documentation here as well. It needs some improving, but yeah, it's useful to know the basics. Okay, so I think I don't want to sleep anybody, so I think probably it's enough for the day. What do you think, Ryan?
I think it was fantastic. I wanted to point out one thing that actually tripped me up when I first started using Fable was the use of discriminated unions on the updating.
Mm-hmm.
I quickly, I think because of my past web experience, that was unfamiliar and I wasn't exactly sure how to use it, but then I actually found it to be very natural once I took a step back and started to think it through it. So I actually found the model view update pattern to be really, really nice and simplify a lot of things that even though you have to make more explicit mappings,
Mm-hmm.
it seemed to make it a lot easier to make sure I was doing the right thing.
Yes.
Which I really appreciated a lot.
Yes, I absolutely share the same feeling. Actually, I have to admit that I'm a late emits user because, as I said, it was Eugene who started, Eugene and Maxime who started, I'm not sure in but you can go, I'm not sure in the screen anymore, but you can go to the Elmis website and you can check. And I was at the time I was using another project that at the beginning I thought it was not fit for Elmis, so I didn't apply it. But after that I applied and I started to learn, and I also became in love with the library and the architecture. And yeah, I absolutely love that everything is just fitting together, and the compiler is always leading you through the good way. And so it's like a puzzle that you just feed the pieces and now it's going to work. So it's also really good.
Yep. Well, this is fantastic. Thank you so much for taking the time out of your day, your evening, I guess, to talk with us and record this video. And I hope others find it very useful. Several people who were on the chat were commenting that they appreciated it. And one person actually mentioned that they were planning to be doing other things and stuck around because this was so interesting. So thank you again for doing this. And we look forward to some more and FableConf later this year.
Yeah, thanks a lot. I hope to see everybody there. So yeah, and just a very final word is that you can go to Fable.io, and from there you can go to the GitHub and you can open an issue if you find any problem. And there is also a Gitter room, and you can find the link also very quickly in the web page. And you can ask the community if you have a small question. And in the docs, there's also a link to Awesome Fable, which is a list of community resources. Besides the documentation, also more samples, more tutorials. So there's plenty of stuff if you're interested in Fable.
Excellent. Thank you, Alfonso. This has been a wonderful presentation. Thank you all for joining us on the Community for F# Hangouts, and we'll hopefully have one again soon.
Thanks.
Have a good day.
You too.